Okay. In Unit 1, you guys learned about some new theorems. Not the Pythagorean theorem, but linear pairs are, fill in the blank. Linear pairs are supplementary. That was a theorem. Vertical angles are congruent. Okay, those were called theorems. What I'm going to show you today are what are called a couple postulates. And it's not important that you need to know that, all right? But what postulates are something that we just assume is true. Okay, it can't be proven true. All right, like linear pairs are supplementary or vertical angles are congruent. Okay? So here's my question I'm going to throw out to you before we do an actual proof. I'm going to start at the high school. Could you guys give me directions on how to get to the middle school? Very detailed directions, please. Could you do you know the streets of Del Mar that well? Where you could get me right here from the high school to the middle school. Maybe some of you could, maybe some of you can't. Good. What would you do if I said there's construction going on Delaware Ave where the four corners are? And I couldn't drive through there. So that's not a way I could get to the middle school. Could you still get me there? Some of you could probably. You got an alternate route? Okay. That's basically what a proof is I'm going to give you information and I want you to get me to a place in the proof statement. How are we going to get between here and here? Your vocabulary knowledge. What's supplementary? What's midpoint? What's bisector? And today, I'm going to give you some postulates that'll connect everything. Okay? Because unfortunately, I know it may be tough for you guys to hear this. Your vocabulary knowledge might not be good enough. You need some extra help to get from your givens to your proof statement. Okay? So let's go over those three connectors right now. Here we go. First one is called the reflexive property. This is one we're going to use in our proofs. This will go in the reasons column if we need it. This will go in the reasons column if we need it. Reflexive property. Go ahead, read what the reflexive property is. I love reading this every year with the kids because they're like, duh. Right? A quantity is equal to itself. AB equals AB. Oh, really? Thanks for the update, Mr. Carlino. Shocker. Breaking news, right? Angle B is equal to itself. Wow. I'm impressed. Not. Right? Everyone? Okay, that's fine. I get it. You're going to see how we use it at the end of class today, though. You're going to be like, oh, all right. This is where I need this. Okay? So just believe me on that. We're going to use this in a second. So let's go to the next one, which is substitution. You guys have used substitution in algebra before. Remember these days? 3x minus 7, x equals 5. What'd you do with the 5? What'd you do with 5? You took it and substituted it in for x, and then told me the value. That's algebraically. We can do it geometrically now. Take a look at my first example right down here, my statements reasons column. I'm going to we don't need a diagram to look at. AB is twice the length of AD. Everyone good? AB is twice the length of AD. AD and DB are equal. Can you use substitution to write me a statement in number 2 that's true? Using those two facts I gave you in number 1. Can anybody apply substitution here? AB is equal to twice the length of AD, and AD and DB are equal. Can somebody plug it in for me to write a true statement now? True statement. All right, here we go, Radhika. You're going to start us off today. Okay, what do you have?
AB equals DB.
AB equals DB? I think you're forgetting a number. AB is equal to, see how there's a 2 there?
Yeah.
So 2 times.
Oh, 2.
Good with me there? Everyone see what we did? Here's exactly how we got that statement. Watch the substitution in action. AD equals DB, so I took DB and substituted it in for AD above. Good? That's how we got that. Substitution. That's how it works geometrically. Everyone at home, all right, how I did that geometrically. because you're going to do it for me right now in the next one. Angle A and B add up to 90, but A and C are equal. Can you come up with a true statement now using substitution? Try it out on your own, and then I'll call on somebody. This is driving me nuts where this is. There it is. So, 16, here we go. Kyla, hi, how are you? Got a response for me?
Yeah.
Go ahead, what do you got? What's a true substitution here?
Measure of angle C plus the measure of angle B equals 90.
Angle C plus angle B equals 90. Great job. Great job. Where'd you get that from? Right here, guys. Take a look. She took angle C, and boom, substituted it in for A. All good. Substitution. At the end of the day, I'll put these over on the board over here. So we have reflexive. We just used substitution twice. Everyone's good. Our final one for today. Everybody at home good on substitution? Okay, our third and final one today. Pinwheels, right there. Pinwheels, kids, pinwheels. It's called addition. The addition postulate. Here's what I'd like you to do, because I want to do a visual representation of this. Everybody draw me 2 line segments right now that look about the same length. Just freehand it. Give me 2 line segments that look about the same length. Can you please call one of them A and the other one of them B? Other one B. Thank you. And off to the side of that, can you do 2 more line segments that are equal, but not equal to A and B? Okay? So you have 2 pairs of line segments that are congruent. Everyone good? Here's what addition says. If you have 2 pairs of congruent quantities, everyone see I have 2 pair. Ready? 1 pair, 2 pair. Everybody good? All right, just want to make sure we know what pairs are there. 1 pair, 2 pair. If I add them together, the results will be equal. That's what addition says. If you take 2 pairs of equal quantities, add them together, the results are equal. So here's what I'm going to ask somebody right now. Can somebody give me 2 line segments added up that equal another 2 added up? That's what I want right now. Okay, can you give me a pair you add up and it's equal to the other pair? Use A, B, C, and D, please. 25, here we go, Sabrina. What do you got? Give me a pair I can add together. And what do you want to add to A? Oh, I don't want to add B, though. Right? Because if I add A and B, that's not going to be equal to C and D when I put them together. Right? Let's say I add A and C together. If I put those together, add those 2 segments together, it's going to be the same length if I added what together? B and D. Do we see that? Right? Because these are equal in length. C and D are equal in length. So if I join A and C, that should be the same length if I join B and D. Everyone see how that worked? Why is that true? Because of the addition postulate. Let me keep challenging you. What else could I add up and it would still be the same length at the end? What else could I add up and it's still the same length? Ooh, going to the top. Vinny, go ahead. What's another pair I could add together?
You could add B and C.
Yep. And that'll be the same length as if I added what?
A and D.
Good job. See how addition works. But you need 2 pairs of equal quantities to add anything. Okay? Kyla, go ahead.
Is there a subtraction postulate?
There is. That's coming up tomorrow. That is coming up tomorrow. Yep. Other questions? All right, so we have reflection, substitution, and now addition. All right, the time's here. It's finally arrived. Embrace it. It's time for your first proof. Your first geometric proof of the year. Okay, first, a couple basics about proofs. Everybody see the givens. You're used to that. That's true. I need you to get from these being true to show me why this is true then. Do not make up any. You have 3 connectors, reflexive, substitution, and addition. Please use those if we can. First step, let's get in this habit, guys. First step, mark your diagram with the givens, please. Get in the habit. Mark your diagram. What markings can I put on A, B, and D, E? What markings? How do I show that on a diagram? What are these? Okay. Hash marks, yes, hash marks. I'm just giving you a tough time. Hash marks. So A, B, and D, E, and then I'll put hash marks on B, C, and E, F. For this first one, I wrote in the givens already. You're welcome. You're welcome. Usually you'd have to do that on your own, but just do me a favor. Remember, I always want your statements and reasons numbered. I will flip if they're not numbered. Okay? Number them, please. All right, you ready? Because we got to figure out here how are we going to get from the given to the proof. So I know that A, B, and D, E are the same length, and I know B, C, and E, F are the same length. How do I get to A, C, and D, F being the same length then? Ooh, woo-hoo, here we go, honors. Okay, 14. Ellie, you ready? I'm going to walk with you on this one. Ready to go, Ellie?
Yes.
Okay, here's my first question for you. What must I do to AB and BC to get to AC? What do I have to do to those 2 segments, Ellie, to get to the full thing?
Add them together.
Add them together! And I got one more question for you, Ellie. What do I do with DE and segment EF to get to DF?
Add them together.
Add them. Does everyone see right now? You have to add to get to the proof statement. Everyone see that? Okay. So here's what we're going to write in number 2 then. You've identified that you need to add. Tell me what you're adding together. What 2 segments are you adding together? So let's go back. Review here. Ready to go. Quincy, here we go. What 2 line segments, Quincy, am I adding together to get to AC?
A, B, and BC.
Everyone ready? AB plus BC. I'm adding those 2 together and saying that that is equal to, what other pair am I adding together? AB plus BC is the same as if I added what other pair? 6. Caroline.
If you added DE and EF.
Awesome. Right? That's exactly. Hey, didn't we just do that here in my segment example? That's what we're doing right here. Now you got to tell me a reason why that's true. Why is statement 2 true? And use something we've talked about. Use something we've talked about. What do you got, ladies? Addition. Right? Addition. That's what we just applied was the addition postulate. You don't have to write postulate. Addition is fine with me.
Could we write AD?
No.
Okay.
Addition. You're not done though. That's not what you were supposed to prove. The last line in every proof you do for me this year, the last line is always the proof statement. So the last line should read AC equals DF. That's not what it reads right now. But, ready? Everyone ready? Need a little help first from one of you. 10. Who are we going with? Atticus, here we go. If you add A, B, and BC, give me another name for that, please. Give me another name for that line segment.
AC.
Thank you. AC. You're not off the hook yet. Give me another name for DE plus EF.
DF.
Everyone see what we just did? Well, what did I just do? Well, what did I just do? I just renamed AB and BF, BC, AC. So all I did was what? Okay, keep going. I took AC and substituted it in. I just use substitution here. I took AB plus BC and substituted in AC because they're equal. And then now, is that what I'm asked to prove? So you're done. You're done right there.
So you don't need to, like, even though it wasn't necessarily given that, like, it wasn't stated directly that AC equals AB plus BC, you can just know that.
By looking at the diagram, yes. Yep. Okay. Hey, that was a big moment right there, and we need to celebrate. Okay, we need to celebrate right now. This is a tradition in every honors class I've taught. After you do your first proof, no, we need to celebrate and let people know that you've just done your first proof. So if you would like, at home, in class, you can take out your phone, grab a little selfie, throw it on the Snapchat, the IG, whatever you guys are using nowadays. All right, and save this sucker, send it to your friends right now, because it is a big moment in your mathematical career. So if you would like, I'll give you a couple minutes to do so. Snap a little selfie with your first proof ever. Usually in other years, we get together in groups and pairs and take pictures with our friends, but obviously that can't happen. Please, come on. What do you think? You're better than that? Get out of here. Get out of here. Celebrate your first proof right now. Go ahead. You at home, don't even tell me at home you think you're better than this. Come on. Celebrate your first proof right now. This is a huge moment. Anybody that's ever taken this class will know what it's all about. Yes?
My class did proofs last year.
In algebra?
You did.
At least I
We did partial proofs, so half, like a quarter of it was filled in, and then you just had to fill in some blanks.
It wasn't algebraic. I think it was geometric proofs too.
Statements and reasons?
Yeah.
There you go. Good job. There you go, guys. People taking pics. Yep, good. Big moment. Your first proof ever. There we go. That was a little anticlimactic, but thank you guys for participating. That was fun celebrating. Now the bad news. This is probably one of 300 proofs you'll do this year, and that's not an exaggeration. We still got 2 more to do today, and there's 3 right there. Okay, it seems like every unit we do has different types of proofs in it. So this is one out of about 300. So congratulations. All right, here we go. One doesn't make you great, right? Let's go to the next one. So now that you guys have kind of the feel for the proofs.
Mr. Colino,
Oh boy, yeah.
my dad's a stickler. He wants to know what I did a proof of.
You
Proof of the proof.
You proved that 2 line segments were congruent. Okay, prove 2 line segments are congruent. And now you're about to prove 2 angles are congruent. All right, here we go. This diagram is going to be used for number 2 and 3, just a heads up. All right, this diagram is going to be used for proof 2 and proof 3. You guys, you can either write in your givens right now or mark your diagram, but you got to do both before we start. Okay, so I'll give you a second. I do get nervous when you guys mark your diagram here. Do you know how to find those be serious here with me. Do you know how to find those angles? Angle ADF is right here, everybody. And angle CBE is right here. So those 2 angles are congruent. My biggest worry is even at an honors level, you guys don't know how to find angles. And I'm being serious. EDC, where is that angle? EDC. So that's going to get double arc marks for me. And ABF, going to get double arc marks. And then go ahead and write in your givens. Remember, that's always your first statement, is your givens. And then once you've done that, take a moment to look at your givens and then look at your angles I'm asking you to prove equal. And say to yourself, what could I do with those given angles to get to those angles I'm trying to prove equal? Okay, take a look. And most of you, if you're starting to pick this up, today's not bad at all. It's when I add more and more of our postulates and theorems, it gets a little complicated. Today, I only got 3 to worry about. So everyone go ahead, take a look at the angles you just marked congruent. What can I do to those angles to get to angle ADC and angle ABC, which are the two I'm trying to prove equal? All right, what can I do with those angles? All right, here we go. Sinjin, here we go. What can I do with those angles that were given, Sinjin, to get to ADC and ABC in my proof statement?
Can you give me a hint?
Well, you got 2 smaller angles, right? And I'm trying to get to the bigger angle. So these 2 right here. What can I do with those 2 to get to the bigger one?
You can add them.
There we go. I think we found the big missing puzzle piece, haven't we? It's going to be addition. But stop, please. Stop what you're doing. You cannot write down that word addition until you have how many pairs of equal quantities? How many pairs do you need to be given to add up together? 2. Look in your givens. How many did I give you? How many pairs? 2. Okay, you can add them. Okay? I make a big deal because if you want to use addition, you better be adding together 2 pairs of equal quantities, and they better be given to you. All right? So, here we go. We figured out it was addition. I need somebody to tell me, what are you adding together? What are you going to add together? And remember, add the correct angles together so you get the bigger angles. Woo! Let's roll. 21. Zach. What are you going to add together?
I did ADF plus CBE.
AD. Whoa, I got to slow it down here. Angle ADF, and what'd you add to ADF?
Angle CBE.
CBE. These 2 you added together?
Oh, sorry, EDC.
There you go. One job. EDC. Everyone good? We add those and say that's equal to. What other pair are you going to add up that are going to be?
CBE
Angle CBE
and ADF.
plus ABF. Nice work.
Why is it angle CBE as opposed to CBF?
Doesn't matter. They're both the same angle, Sophia. Both the same angle. So I don't care how you name it. Okay? You could go CBF, CBE, CBD. All the same angle. All right? And this was by, what gave Zach the right to say that was true? What did he do with the angles? Addition. Don't write add, it's addition. That wasn't my proof statement, though. I didn't ask you to prove that. I asked you to prove ADC was equal to ABC. So, 19, here we go, Sean.
We add AD.
Ready? Hold on. ADF plus angle EDC. If I put those together, what angle do I end up with?
ADC.
ADC. And if I put CBE together with ABF.
That equals angle ABC.
Yep.
That's substitution.
And that is substitution, what you just did. How are we feeling here? I know many of you are thinking this right now. This is so easy. I just write addition and substitution and I'm done. Wait till we get to number 3. It's not all like this, okay? All right, speaking of number 3, same diagram we just used. Spin just came out, spin. All right, given DE equals BF, mark it. I should see hash marks somewhere on your diagram. DE equals BF. Let's put it in our statements. Look at your proof statement. Look at the two segments I need equal at the end of this. I need DF and BE to be the same length. Ooh. It's weird. So I'm asking you, how do I go from DE and BF to DF and BE? How do I go from this one to that one? Here's my first question to you. Look at those two segments. Everybody look at DE and then look at DF. Are you getting bigger or smaller? Bigger or smaller? Oh, 19 again, Sean.
Bigger.
Everyone agrees you're getting bigger. So usually when you get bigger, don't you have to add something onto it? Right? Okay. What do you need to add on to DE to get DF? What segment do I need to add on to DE to get to DF? Oh, 5. Here we go, Hayden. What do I need to add on to DE to get DF?
EF.
Okay, I got it. Thank you. EF. All right, next question. What do I need to add on to BF to get to BE? You said get bigger, so how do I get bigger? What do I need to add on to BF here? Oh, going down to 8. Ryan? What do I have to add? Oh, sorry, go ahead.
FE.
FE, which is another name for EF, right? Wait a second.
Yeah.
Wait a second. So you guys are telling me in both cases, I need to add on what to my givens? EF. And what do you know about EF and EF? They're both equal. Why are they equal? Hello, this is where it comes into play. Because of the reflexive property. Okay? And, ready? Before you write addition, how many pairs of equal quantities do you need? 2. But in this case, how many did I give you? 1. So when you're looking for that missing one, it's probably going to come from reflexive, a quantity equal to itself. Okay? So in step 2, you cannot add. You don't have 2 equal quantities yet. I still need to write the second, which is EF equal to EF. There you go. You cannot add unless you have 2 pairs of equal quantities. And how do I know this is true? By what postulate? Reflexive. See how this works? Now what can I do to both pairs? Add them up now. Now you can add, but not until you have 2 pairs of quantity. Now I can add. So somebody out there, tell me what I'm adding together here. Sean, on fire today. What do you want me to add together to get to the proof here? DE plus
EF.
EF is the same length as if I added
BF.
and
EF.
yep. Good job. And this is because of addition. The better you understand addition, subtraction is going to be a piece of cake tomorrow. Except we're going to get smaller instead of bigger. Final step, because that's not my proof statement. Final step. 18. Oh boy, here we go, Owen. Give me another name for DE plus EF.
DF.
DF,
And then
BF plus EF,
DF.
B, F,
Or E.
BE. And we use substitution. Okay. How you guys feeling? We all right?
I'm not quite sure I understand the addition postulate completely, but I think I understand how it works. Like I understand how I can use it.
Okay, Sophia, you have 2 strings in front of you that are the same length, right? Then to your right, you have another set of strings that are the same length. Put one string from pile 1 with another string from pile 2. Put it together. Put the other 2 together. What are you going to know about their lengths? Your new string lengths. What are you going to know about them? They're the same length. Why are they the
Okay, I
same?
think that helps.
Why are they the same length? Because of the addition postulate. It makes, Sophia, it's kind of like this. It makes sense in your head, but you just got to put a name to it now. Okay, which we're putting the name addition postulate to it. Okay?
Yeah, thank you.
Yep. Other questions? Okay, I really just don't want you to feed you to the wolves and let you go with homework. I just want to give you a couple hints on the homework here. Okay, so let me just go through the homework so you know exactly what's going on. Numbers 1 through 4, you're just using, what postulate am I using here? Okay, what postulate am I using? Okay, I'll let you go through that. It's not a statement's reasons. It's just name the postulate we use today. Okay? Everybody good there? So you're either going to write, you're going to write reflexive addition or substitution. Okay? All right, stay with me. When you start on number 5, then you start with statements and reasons on number 5 when it says write a formal proof. All right, now, guys, please listen here. I'm going to warn you, all these proofs don't look like given, addition, substitution. Like, I'll do number 5 with you right now just to show you that they all don't look like that. Everyone see our givens on number 5? NP equals 2 inches, QR equals 2 inches. So why does NP equal QR? This has nothing to do with addition. Nothing. Statement 1 is going to be your givens. And then statement 2, anybody know how I can get NP equal to QR? It has nothing to do with addition here. Remember, we haven't used that, so don't use it. Try to use something that we've used already today. Don't make up your own stuff. All right? Yes? Well, reflexive means it's equal to itself. So NP would be equal to NP. QR would be equal to QR. Okay? Yep, take a look, guys. Ready? If QR equals 2 inches, can I take QR and do what where I see another 2 inches? What did I just do there? Substitution. So step 2 is just substitution. That's it. Okay, so I don't want you to assume that it's all given, addition, substitution, because it's not. Some of them will be, all right, but not all of them. All good? Last thing, and I'll let you go on your own and work on your own because we still got plenty of time. Can you guys go to number 8, please? Number 8. I already gave you the hint right here. Use more than one substitution. Okay? So here you go. My best bet right now, take 2 of them. Like, here you go. Ready? Take those 2 right there. If ZY equals WX and YZ equals ZY, can anybody come out with a conclusion right now? Just look at those 2 right there. ZY and WX, WZ and ZY. Can anybody come out with a conclusion? What's got to be equal to each other then?
WZ equals WX.
WZ equals WX by substitution, right? Everyone good? Then, ready? I'm trying to make this as easy as possible. Then use these 2 right now and do substitution and see what happens. So 2 substitutions in that one. Okay? All right, I'll let you guys go. Work on your own. You guys online, you guys at home, stay online, please. Remember, there will be no answers because I want to see what you can do on your own. It's okay to struggle. It's okay to struggle. Please stay online.
Is there any time where the first statement is not restating the given?
No. Nope, because usually you need those statements to get to your next statement. So that's why it's got to be first.
Could you mark the diagram in number 6? Like, would you be able to show that angle B is equal to both angle C and A?
Yeah, you would probably have single arc marks on A, B, and C, right? Yeah. And that makes it easy. Why is A equal to C? It's just a simple one substitution, and that's it.